All right, howdy. We're going to do an advanced example of the chain rule now, and it's advanced because we'll have to do sort of a chain rule within a chain rule problem. So here's a typical example of how these things come up. You might have the square root of x cubed plus the square root of x to the fourth plus x to the fifth. All right, so as you go about this problem, you notice sort of the outside part of the function is just the square root function, which you can also write as x to the 1/2. Whereas the inside part, the thing that you're plugging into the outside function, is much more complicated. It's x cubed plus the square root of x to the fourth plus x to the fifth. And you see the inside part already has a composition of functions in there as well. So we'll deal with that as we get to it. But the trick is really to not let it freak you out. Just follow the rules step at a time, and it'll all work out in the end. All right. So this derivative, what the rule says is, first of all, you take the derivative of the outside function. So the outside function is x to the 1/2. So its derivative is 1/2 x to the minus 1/2. And then you have to plug in the inside function. So we write it this way, evaluated at the inside. X cubed plus the square root of x to the fourth plus x to the fifth. All right? But then I have to take the derivative of the inside. Instead of, as I did in the previous examples where I just wrote down the derivative, because this is more complicated, I'm going to just say take the derivative of it. So I have to do the derivative of the inside part. X cubed plus the square root of x to the fourth plus x to the fifth. So that's what the chain rule says. We took the derivative of the outside, plugged in the inside, and then we had to multiply by the derivative of the inside, and I just haven't calculated what that derivative is. I'll do that in the next step. All right, so let's plug in the inside here. We get x cubed plus x to the fourth plus x to the fifth, all to the minus 1/2 power. And now I've got to do this derivative here. But you see, this part will have itself a chain rule problem going on. So let's do it actually even slower. So the derivative of a sum is the sum of the derivatives, so it's 3x squared plus whatever the heck the derivative of this is. All right. Now this is, to evaluate this last derivative here, this is another chain rule problem. So the outside function is the square root of x, also written as x to the 1/2, and the inside part is just x to the fourth plus x to the fifth. So that when I write the derivative, well, let's copy everything else first. 1/2 x cubed plus the square root of x to the fourth plus x to the fifth, all to the minus 1/2, times 3x squared. And now we're going to do the chain rule here on this part. So the derivative of the outside is x is 1/2 x to the minus 1/2. And then I have to evaluate at the inside. So that's x to the fourth plus x to the fifth. And then I multiply by the derivative of the inside. And this I can just write down directly because I know those rules. So it's 4x cubed plus 5x to the fourth. Close my big parentheses. And now we do the plugging in. We get 1/2 x cubed plus x to the fourth plus x to the fifth, all to the negative 1/2 power, all times 3x squared, 1/2 x to the fourth plus x to the fifth to the minus 1/2 times 4x cubed plus 5x to the fourth. And that's it. So it's pretty ugly, and probably no one ever cared about this function, but that's how you take the derivative. All right. See ya.